Pranav,
No problem.
Prameya?
No problem.
Okay, right, okay, right. Okay, so this question is quite simple, no, children? The cell
Ma'am,
represent the cell?
you share the screen, ma'am.
Yeah, okay. Represent the cell, and they are asking you to calculate its E cell. You see E naught is missing, right? Right? So it shows what? It shows something, I don't know. Let us see how much can I record. Okay. So in this case, you are supposed to calculate the E cell. E cell because the concentration is no longer 1m. Clear?
Yes, ma'am.
Okay. So your Nernst equation says E cell is equal to E naught of cell minus. Okay, you don't see 2.303 RT. That is because this is to the base E. Right, children? This is to the base E. What was the Nernst equation? E cell is equal to E naught of cell minus minus 2.303 RT by NF log. Now, when I wrote this expression or Q expression, I meant the log to the base 10, whereas here the log is to the base E. The conversion factor from log to the base E to log to the base 10 would be 2.303. Any problem with this expression?
They should provide the log value for
They
0.93.
will provide you every value, ma. In fact, even in this NEET exam, they provided every log value. Okay. Even in the NEET, they provided. So why wouldn't they provide you in the NCERT exam? Understood? So they will provide you the log values and they won't provide you log values to the base E. They will provide you log values for the base 10 only. Clear? Clear?
Yes, ma'am.
Okay. Now, so it is what you need to take care of is the balanced chemical equation and incorporation of the coefficient. See, 2Ag plus. So, Ag plus concentration to the power 2 and magnesium ion concentration to the power 1. So, this much care you must take, okay, to calculate. And I told you this will not be very, very tedious, ma. Okay, you were asking, no, Prameya, can I put it as 0.06? It won't be very tedious calculations. So you can still manage. It is not like equilibrium lesson and all, no?
Yes.
So we can manage. Okay. Okay. Similarly, calculate the equilibrium constant for the reaction. Copper plus 2Ag gives copper 2 plus and 2Ag. E naught of cell is given. Now we know the various expressions. What are they? We know del G naught is equal to minus NF E naught of cell. Otherwise, minus del G naught is minus 2.303 RT log of K. Or we know this expression. What is that expression? When the E cell in the Nernst equation becomes 0, when the E cell in the Nernst equation becomes 0, the Q becomes K. In that case, it will be E naught of cell is equal to 2.303 by N, which is 0.059 by N log of K. So, in other words, you can put it as N times E naught of cell by 0.059 is equal to log of K. So, this expression can also be used directly, right? That's what they have used here. So, what is log of Kc? Log of Kc will be N times E naught of cell by 0.059. So either you substitute the E naught of cell. If you want to go by the long route, what you will do? You can equate this term with this term. Ultimately, you are actually doing this only. minus NF E naught of cell is equal to minus 2.303 RT by RT log of K. If you cancel the negative signs and take this 2.303 RT here, 2.303 RT, the 2.303 RT and F put together is only 0.059. So ultimately you are actually writing the same formula again and again. Okay. So sometimes they will ask you to calculate del G. In that case, the E naught of cell can be taken up for the calculation of del G. So this is going to be left out as log of K. Is it clear, children? Any problem in this? Any problem?
No, ma'am.
See, here log of Kc, it's your duty to find out that it is 15.6. They will provide you the anti-log of 15.6. If log of Kc is equal to 15.6, then anti-log of K only will give you the Kc value. Anti-log of K, this log of Kc will be anti-log of 15.6, which is 3.92 into 10 to the power 15. So they will provide all the required log and anti-log values. So do not worry about it. Okay. That is clear. Let us just take up this question. This is also a simple question. Any problem in this? Check example 2.3. Check. Any problem in that? Calculate the standard Gibbs free energy change. Any problem in that?
Ma'am, if do we take it as 96
96500 coulombs you take. Nothing wrong.
okay.
Okay, you don't have to take 96487 and all. You take 96500. It's very, very acceptable in the board exam. And it's not must unless they ask you, it's not must to put it in kilojoules per mole. You can put it in joules per mole. If they ask you to put it in kilojoules per mole, you do it. Otherwise, not required. Clear? Simple problems?
Yes, ma'am.
Okay. Now, coming to this particular question. Okay. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. Okay. What are they trying to say here? See, we wrote Nernst equation for a single electrode. Remember, from there we went on to write for a cell, correct? Yes?
Yes, ma'am.
So, we wrote the E electrode as E naught of electrode minus 2.303 RT by again NF log of the reduced species by the oxidized species. Okay, say for example Zn by Zn plus 2. Okay, so Zn by Zn2 plus, something like that, reduced form by oxidized form. This is for a single electrode. It's not for the cell, it is for single electrode. So in the question, it looks like it is about a single electrode, isn't it? Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. So supposing the pH is 10, that means, can we say negative log of hydrogen ion concentration is 10? Yes. Or we can put it as minus of 10 is equal to log of H plus. What will be
Yes,
H plus ion concentration? Can we put it as 10 to the power minus 10? Only if the H plus ion concentration were 10 to the power minus 10, the pH, which is negative log of H plus, will become 10, no?
yes. Here log is log to the base 10, right?
Log is
Log to the base 10, right?
everything. See, in
Like,
chemistry, if I want to say to the base E, we will put the term ln. And if I want to tell that it is
okay.
to the base 10, then we will put it as log. Any doubt in this?
Uh-huh. Got
Throughout. Is it okay? Throughout. If it is ln, to the base E. If it is log, to the base 10. Okay. So look at this. If the pH of the solution is 10, That means the H plus ion concentration is 10 to the power minus 10. Do you have any problem in this?
Mm-hmm.
So, in this particular question, which is hydrogen electrode, about hydrogen electrode, can we say 2H plus 2 electrons is becoming H2? All the electrodes must be written in the reduction method, reduction process. So, what will this be? E of H plus 2H2 is equal to E naught of H plus 2H2 minus this whole thing can be generalized now as 0.059. You don't have to write it separately. You don't have to show the full form and then condense and all. You can straight away write 0.059. Now, the number of electron transfer, how much is it? The number of electron transfer is 2. Okay, log of the reduced form or simply the product by reactant. So, product is H2 by reactant is H plus to the power 2. Okay, what is E naught of H plus to H2? What is the
0,
standard?
ma'am.
0. So this is 0 minus 0.059 by 2 log of hydrogen. Now in a standard hydrogen electrode, the hydrogen gas is pumped at 1 bar pressure, isn't it? So we'll take it as 1 and nothing special is mentioned. That means it is usual 1 bar. What is the H plus ion concentration? The H plus ion concentration is 10 to the power minus 10. This is, yeah. So we'll put it here 10 to the power minus 10 to the power 2. So what do I get? I'll get minus 0.059 by 2 log of 10 to the power 20, or we can put it as 20 log 10. Or we can put it as log 10 is anyway 1. So this becomes minus 0.059 into 10, or you can put it as minus 0.59. Okay. Now, if you are seeing this question in a competitive examination, okay, if it is for the NCERT sake, that is CBSE board examination, you will have to do all this. Put it in volts. But if it is for a competitive examination, then straight away what you can do is the E of this electrode will be pH times, okay, minus pH times 0.059. That's it. Do you get the answer? Minus of pH times. So minus 10 times 0.059. Yes, those who are doing the competitive examination, minus of
Yes,
0.59. That's it. Got it? But in CBSE, they will expect you to write all this. Clear, children? Clear, all three of you?
yes, miss.
Ishan, Pranav?
Ma'am, this log of H plus equals to minus 10, then how it become 10 to the power of minus 10?
Okay, anti-log of minus 10. What is
Okay, ma'am.
anti-log of minus
100.
10? Anti-log of minus 10, man. You
What is
see,
it?
see, if you say pH, okay, I'm giving you a simple case. Why to do all that? Supposing it is 0.01 mHCl solution. How do you calculate the pH? pH
Minus
is,
of log H plus.
okay, what is H plus here? 0.01, which is 10 to the power minus 2, right?
Yes, ma'am.
What is the pH then?
Log of 10 to the power of minus 2, 1 by 2. Okay, 2.
2. So, if the concentration is 10 to the power minus 2, then pH will become 10, 2, na?
Yes, ma'am.
Okay, if the pH is 10, then H plus ion concentration would be 10 to the power minus 10 to make it 10, na?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Understood? Or take
Yes, ma'am.
anti-log, use the scientific calculator, take anti-log of minus 10. What do you get?
Yes, ma'am. 10 to the power of minus 10.
That's all. So if pH is, supposing the concentration is given as 10 to the power minus 2, then pH will be minus log of 10 to the power minus 2, which happens to be 2. So if concentration is 10 to the power minus 2, you get pH 2. If pH is 10, what would be the concentration? 10 to the power minus 10 only, no?
Yes, ma'am.
Got it? Any
Yes, ma'am.
doubt about this? So this will
No.
be the shortest way of doing it in the competitive examination. This may not be accepted in the CBSE examination. Clear? There you have to write the Nernst equation, substitute, declare that E naught of H plus to H2 is 0 volt, find out and report it in volts. Okay. So I'll proceed to next question.
Yes, please.
Will there be any problem in 2.5? Please check and tell me. And
I actually
2.6.
had a doubt in that.
Which one?
The 2.5. Like,
Oh, why a doubt? Calculate.
what is the difference between EMF and electrode potential?
See,
Is there a
you are
difference?
you are talking about this potential electrode.
Yeah.
See, when you are talking about a single redox couple, H plus in contact with H2, you call it as electrode potential. If the H plus concentration is 1 m, you call it as standard electrode potential. Any doubt?
No, I got that.
But when you are combining two electrodes, say for example H plus H2 is combined with Zn 2 plus Zn, then now it becomes a cell, na? In that case,
Yeah.
you will calculate the E cell or you call it as EMF. If it is under standard condition, you call it as E naught of cell. That's all.
Okay.
Any doubt, children?
No, got
No, ma'am.
Okay, right. So this question, will there be any problem in 2.5?
No, ma'am.
No? Pranav, is it okay?
Yes, ma'am.
You are provided with E naught of cell. So you are calculating the E cell or EMF of the cell. Both are same. EMF or E cell is same. So E naught of cell minus of 0.059 by N log of straight away products by reactant. So it is Ni plus 2 concentration to the power 1 into Ag concentration to the power 2. But again, that will be taken as 1 only and divided by the Ni concentration into Ag plus concentration to the power 2. So these two you declare as 1, Ni plus 2 concentration and Ag plus concentration you supply. Simplify and you will be given the log of that value. Substitute that value, calculate the result. N will be how much in this case? What will be N? Nickel is becoming Ni plus 2 electrons and 2 Ag plus is becoming Ag. What is N value?
2 electrons, ma'am.
2 electrons, not 4 children. It's not the total. It's the number of electrons lost or gained. So it will be only 2. That's it. Okay, the next question is also a regular trivial question. Standard Gibbs energy and the equilibrium constant you are given with E naught of cell. We have got direct relationships for that. So we don't have to worry. Del G naught is equal to minus NF E naught of cell. E naught of cell is given. Look at the equation. Get the N value. What is N value in this case? 2 Fe3 plus is
2.
becoming 2 again. Any problem with that? The anodic reaction is what? Anodic reaction is 2I minus is oxidized to I2, giving out 2 electrons. Cathodic reaction is Fe3 plus 2 electrons is becoming 2 ferrous ions. This is always a question. Generally, they will ask you, write the anodic reaction and cathodic reaction. This is anodic and this is cathodic. Any problem, children? Any
No,
problem?
ma'am.
Can I proceed? Okay. In your textbook, also similar questions. Nothing different, children. Nothing different. I'll just mark which questions are related to this. Very, very straightforward questions they are. Like this question. You are given the cell representation. And you are asked, write the Nernst equation and calculate the EMF at 298. Okay. Does any one of the cell representation bother you? Please tell me. What is this PT? Are you getting any doubt?
Platinum though,
Why? Why platinum is mentioned?
because it's a standard electrode.
Also, if anything in gaseous state is involved, you need a surface on which the reaction should happen. So you are providing hydrogen gas, a metal surface for the reaction to happen. What is this? This is bromine in liquid state mixed with the bromide salt solution. You need a surface on which there is no solid involved, no, in this case. See the fourth one. Is there any solid surface on which the exchange interface clear Kuma? There you want the surface on which electron gain or electron loss should happen. Do you have anything there? Therefore, you use platinum. Anything else? Please do write the Nernst equation for the fourth one and tell me. Please do write the Nernst equation for the fourth one. Platinum in the solid state, bromide ion 0.01 m, Br2, H plus concentration 0.030, okay, and H2 at 1 bar. Platinum acting as the surface on which the reaction is occurring. Come on. Frame the equation first. Can you frame the equation first? Because when you frame the reaction, it's very easy to put products by reactants, remember? And when you write the equation, you will balance it also. You will not miss the coefficient. You will not miss the power. Clear, children?
Yes, ma'am.
To write the equation, what is getting oxidized?
Bromine, ma'am.
Bromide.
Bromine, sorry, ma'am.
Bromide is becoming
Bromine gas.
bromine gas or bromine liquid actually. Okay.
Yes, ma'am.
So it must have lost electrons. How many? It would have lost 2 electrons. Okay. And the 2H plus gains those 2 electrons to become H2. So when you write the Nernst equation, the EMF of the cell is equal to E naught of the cell, whose values you can pick from the table. Since it is an NCERT question, they are just leaving it to you. Minus 0.059 by n log of. What will you write on the numerator and denominator, children?
PR's concentration by H.
இல்ல அதுதான் இல்ல. See, I told you
Oh,
BR
product
is
by
liquid.
reactant. Br2, this is an unusual case, Aprameya. H2 concentration by Br minus concentration to the power 2 and H plus concentration to the power 2. That's why I told you, if you write the equation, it serves many purposes. When you want to write the Nernst equation, you simply take the products divided by the reactants plus each of the reactant or the product to the power of coefficient. So there is no chance that you will miss anything if you write the equation. Clear?
yes, ma'am. So, what concentration will we take for BR2 and H1? Right?
Br2 is a liquid, and in equilibrium constant, any liquid and
We
solid
don't
you will take
take it.
1.
Yeah.
Na? So this becomes 1. This also becomes 1 only.
Yes, ma'am.
So both the Br minus concentration will be 0.01 and H plus concentration is 0.03 to the power 2. Solve this. What is the n value? As
2,
usual,
ma'am.
here it is 2. Here it is 2. That's all. E naught of cell. Now, there is a very interesting thing here. Please note. The E naught value for the bromine electrode is 1.09 volt. Of course, you will go and refer. You don't have to memorize. And this is 0. This is 0 volt. What will happen to the E naught of cell? Check. What will you write for E naught of cell? Isn't it E
Ma'am,
naught of
minus
cathode?
1.09.
E naught of cathode minus E naught of anode. So which is 0 minus 1.09 volts. Is it okay?
It is. Yes, ma'am.
So minus 0.059 by 2 and log of the whole thing you will calculate, which is 10 to the power 3, 9 into, which will be 1 by 9 into 10 to the power minus 8, right? 10 to the power minus 2, 10 to the power minus 2. Here also 10 to the power minus 2 and 10 to the power minus 2. So this is 10 to the power minus 8. So this will become actually 0.1 into 10 to the power 8. 0.1 into 10 to the power 8. It's a positive quantity. That means this stays as a negative quantity throughout. Clear? It will become a negative value only. That means, is the cell functional?
No,
No.
ma'am.
No, that's all. Did they ask you whether the cell is functioning or not?
No, ma'am.
Don't interpret, don't change anything. You calculate for what it is, that's all. So report the value in negative value. So don't be surprised, oh, why I'm getting a negative value. You may get a negative value. Okay, and the result is that the cell is not functional. Is it clear?
Yes, ma'am.
Okay, so these are usual sums. 2.6 is usual sum, very usual sum. Okay, calculate the standard cell potential for the galvanic cell. You are given the equation. Standard cell potential. So you just have to go to the E naught table, get the E naught values for the cadmium and the chromium electrode, identify which is cathode, which is anode, E naught of cathode minus E naught of anode. That's it. Any problem in 2.4, 5 and 6?
No.
What about 2.3? This was there in class 11 also, remember? Depict the galvanic cell in which the following reaction is taking place. So you just have to write which is anode. Zn is getting oxidized to Zn plus 2 and the Ag plus is getting reduced to Ag. You don't have to write 2Ag, please remember. Solid, aqueous, aqueous and solid. Okay. Which of the electrode is negatively charged? Which is negatively charged, children? Zinc or silver? Which is negatively charged?
Zinc, ma'am.
Zinc. Anode is negatively charged. But don't write anode is negatively charged. Identify that zinc is anode and zinc is negatively charged. Okay. The carriers of the current in the cell, always ions. The carriers in an electrolytic solution is always, where the moment you have a solution, it is ions. Okay, individual reaction at each electrode. This is what I was saying. Zn is becoming Zn2 plus 2 electrons and 2 Ag plus. Here you have to balance, right? Plus 2 electrons gives 2 Ag. Is that okay? Can I
Yes,
proceed?
ma'am.
Okay. Okay, next. More the negative E naught. Okay, this is a very, very important question, children. 2.2. Last year also we analyzed, this year also we'll analyze. Identify the metals in increasing order of reducing power. So tell me, which is the best reducing agent and which is the poorest reducing agent? The poorest reducing agent, okay, tell me first.
Ma'am,
Which is,
the most negative value will be the best reducing agent.
okay, further, I want the
So,
perfect answer. Which is the
chromium.
reducing?
No, wait, ma'am. K plus to K is the best reducing agent.
But a reducing agent must be one single entity, na? It cannot be K plus K combination. An electrode is never a reducing agent. Any one particle only will be reducing agent. So you have to point out whether it is K plus or K.
K plus, ma'am.
A reducing agent must undergo oxidation, Ishan.
Okay. Yes, sorry, ma'am. K. Yes, ma'am.
Are you getting the point, children? Yeah?
Ma'am, so when you say reducing power, it doesn't mean reduction power.
Yes, reducing power is same as reductant,
Okay.
is same as reducing agent. All are same. Reducing power, reductant, reducing agent. All the three statements are same. So the best reducing agent will be the one with the most negative sign. What do you mean by most negative sign? Does K plus have ability to get reduced when you look at most negative sign? Will K plus get reduced?
Yes, ma'am.
Will K, Ishan,
Gain of electrons is reduction, no, ma'am. So K plus will get reduced to K.
if you see negative sign, what does it indicate?
Okay, ma'am. That it will oxidize.
Okay. What
So
does it indicate?
K
It
becomes K
indicates
plus.
that the K plus is not ready to become K, right?
Yes, ma'am.
Instead, K is willing to become K plus. That means
Yes,
K,
ma'am.
K is ready to get oxidized. Clear? Aprameya
Yes.
Yes, ma'am.
and Pranav?
Yes.
Okay. So most negative E naught means, please again understand, because in D and F block you have got a lot of importance given to the E naught values. A more negative E naught means not having tendency to get reduced, not ready to get reduced, instead ready to get oxidized. So something which is very good at getting oxidation, getting oxidized will be a good reducing agent. So potassium is the good reducing agent. So which is the poorest reducing agent then? The one with the most positive E naught.
AG.
AG. AG. AG is the poorest reducing agent. So the best oxidizing agent now. An oxidizing agent is the one which gets reduced. Aprameya, tell me, the best oxidizing agent. Analyze again, should I call out the ion or the metal? And tell me, best oxidizing agent.
Ion.
Which ion?
AG plus.
Which one?
AG plus.
Very good. Pranav, the poorest oxidizing agent. The poorest oxidizing agent is the one which is not willing to get reduced.
Potassium.
Potassium,
K plus.
K plus. Understood, children? Understood?
Yes, ma'am.
Okay, very good. So these questions, these are very important results. These are usually asked in the board exam. Now what happens is, supposing, I'm just telling you, were asking, no, how teachers will intervene. Supposing by mistake child writes K plus, what will we do?
Rub the plus, ma'am.
That's all. So these type of small things some teachers will do. I'm not saying everybody does. Understood? I'm not
Yes,
saying
ma'am.
everybody does. Some teachers will do. That may not have happened this year. Understood? Okay. Again, someone says poorest oxidizing agent is K. Then we tend to correct. That is not going to happen. So be careful this year onwards. Okay. Now, second important thing. What is not given in the book, but once what was asked in the board examination was this one. Please understand this question. Okay. So far, we have been talking about, say, for example, I've got a reaction MnO. MnO4 minus is 0.01 m. Okay, Fe plus 2 is 0.1 m plus, okay, this is 5 Fe2 plus 8 H plus with 0.01 m concentration, illa 0.02 m concentration is becoming Mn2 plus concentration with 0.02 and the 5 Fe plus 3 concentration with 0.1 m, let us say. I'm writing my own values plus 4H2O. The MnO4 minus 2 Mn reduction potential is, let us say, 1.56 volts, and for Fe plus 3, 2 Fe plus 2, it is 0.44 volt. Again, the process is actually Fe2 plus is getting oxidized, but you will always be given reduction potential value. Do not meddle with it and use the value as such, even if the species is getting oxidized. I've told you many times this concept, right, children?
Yes, ma'am.
Now, write the Nernst equation for this. Now, the question arises, should I take the 8H plus or not? That's the question under consideration. Should I take the 8H plus or not?
No.
Hmm?
I don't think so. We don't need to do-
Enema?
we don't need to take it back until
We should or we should not? Aprameya.
no. I'm not sure, but I think it's a no. We
You
don't
should
need to
not,
take
you are
it.
saying. Now, I'll put it this way. EMF is equal to, Pranav, what do you think? And Ishan?
I think we should, ma'am.
Pranav? Pranav? Are you there? Yeah. What happened, Pranav? Speak up.
Yes, ma'am.
We should. Should we take the H plus or not?
We should, ma'am.
We should. Now see, was this not Q, Aprameya? Reaction quotient?
Yes.
And this is an equilibrium concept only, no? So anything which is in liquid, anything which is in solid, ignore. Anything which is in aqueous, anything which is in gaseous state, you will take, no?
Okay. Ma'am.
So you will take the H plus. Got it? Okay. Now you have written the balanced equation. So that means product concentration by reactant concentration, Mn2 plus concentration to the power 1, Fe plus 3 concentration to the power 5 by MnO4 concentration to the power 1, Fe plus 2 concentration to the power 5 and H plus concentration to the power 8. Is it okay? What will be the N value? What is N value here?
One, ma'am.
Oi.
No, wait, ma'am.
How to lose marks? What, Ishan?
5 into 3, 15, ma'am.
Aprameya? Pranav?
10, ma'am.
Okay.
10.
15,
10, ma'am.
10. Aprameya. And Pranav. Pranav, speak up.
I'm not
No,
sure.
sir.
Yes, Pranav? Hey, we are delaying the class. If you keep responding late, we are delaying.
Ma'am, I said not sure.
You said what? Not sure.
I'm not sure. I'm not sure.
Aprameya?
No, sir.
Not sure. MnO4 minus has Mn in plus 7 state and Mn is in plus 2 state. So what did it do? It gained 5 electrons. Okay. On the other hand, Fe2 plus lost 1 electron. It lost 1 electron, but that's why it was multiplied by 5 to balance. So what is the number of electrons taken or lost? Or, not and.
4.
5.
5. Ishan, okay?
Yes, ma'am.
So don't add up. Oh, 5 electron lost, 5 electron gain. No. Whatever lost, whatever electrons are taken, it was lost by Fe2 plus only. So lost or gained. Okay. Or LCM. Supposing on one end it is 2, on other end it is 3. It's plus 2 but losing 3. Then take LCM. This has to be multiplied by 3, this to be multiplied by 2. N value will become 6. Okay. I hope this question you will not forget, right? Can I proceed?
Yes, ma'am.
Okay. Now we are going to the next concept, that is the conductivity and the molar conductivity part. Okay. I told you the first part is over. We divided the entire content into actually 4 parts. The Nernst equation part was 1. Conductivity part is 2nd. Faraday's law is 3rd and batteries is last. So we are now going into the electrolytic conductivity. We are going into this concept, conductance of electrolytic solution. Okay. So for a brief time, I'm going to ask you to recollect how the metals would conduct electricity and how the solutions would conduct electricity. In fact, these are electrolytic solutions. Okay. How do the metal conduct electricity?
Electrons.
So they have free valence electrons or loosely held electrons, right? They have
Yes, ma'am.
loosely held valence electrons. How do the solutions conduct electricity?
Ions, ma'am.
Ions. No other answer. Ions. Okay. Now, what happens to the resistance of a metal when temperature is increased?
It increases, ma'am.
It increases. What happens to the resistance of the electrolytic solution? It decreases. Okay. So how the conduction happens, if you understand that, it will be clear. And this is not new to you. In a metallic substance, the inner nucleus and the inner core of electrons will form the positive charge, right? And the valence electrons are present as electron C. This is said to be electron C model, correct? For the metals. Yes, children?
Yes.
So, if you are going to connect, see the nucleus contains positive charge. There are equal number of protons and electrons. Assume that you have got 2 electrons in the last shell. Rest of it, right, will be taken up as the kernel. We call it as kernel. These are positively charged. Why? Because in this space, there will be 2 less electrons than the protons. Assume that the total protons are 20. Assume that the total protons are 20. That means you have got 2, 8, 8 and 2. So you've got 20 protons but 18 electrons in what I have circled. So these 2 electrons are free, which forms the electron C. So it's positively charged kernel surrounded by those 2 free electrons. So the moment I connect it to a battery, assume that this is the negative terminal. The negative terminal, now we are very clear. The negative terminal is the anode. Anode is the place where electrons are generated. Electrons are fed inside. When electrons are trying to go, the positive terminal will withdraw 1 electron from the metal. this electron jumps. That creates a vacancy. Electron from the adjacent moves into the vacancy, vacancy moves. So vacancy is the hole or the empty space which moves in this direction. Electrons keep moving in this direction. Is that clear?
Yes, ma'am.
Okay. But in the case of solutions, it is the ions which should move. So with increase in the temperature, kinetic energy of the ions will increase. And they will be more mobile to go to the anode and cathode, right?
Yes, ma'am.
So as temperature increases, the resistance decreases. Resistance is the ability of a material to oppose the flow of current. If you increase the temperature, ions are more mobile. They are good conductors. They are better at moving. So resistance decreases. This is the most important, and these are the two most important and striking differences. The charge carriers in a metal is electron. Resistance is directly proportional to temperature. The charge carriers is the ions, and the resistance is inversely proportional to temperature. Any doubt in this?
No, no.
Okay. Now for the metals, we have been using some of the standard expressions. R is directly proportional to length of the wire, inversely proportional to area of cross section, correct?
Yes, ma'am.
Yeah.
Yes, ma'am.
And then we used to introduce a proportionality constant which was called as resistivity. Right? R is equal to resistivity times L upon A. L upon A is called as cell constant in the electrolytic solution. So this is something which is usual. The resistance of a metal is expressed in terms of ohms. If anything new, please let me know. If there is a metallic wire, then the length of it is L and the area of cross section is A. Resistance is directly proportional to the length because you can now physically understand an electron has to penetrate and go to the other end, correct? More the length, more the hurdle, na?
Yes, ma'am.
Whereas if you melt down this and increase the diameter and reduce the length, electrons face less resistance. Electrons are free to move and they need to travel less length also. If the same metal is molded into a cylinder, okay, of a smaller length but greater surface area, then obviously the electrons will be more free to move and they need to cover less distance. So less the length, more the area, less the length, more the surface area, lesser will be the resistance. All this you have done it in 10 standard, correct? How do you define the
Yes,
resistivity?
yes.
It's a constant. How do you define the resistivity? I'll remind you something. Del TB is equal to KB times M. How do you define the KB? KB is KB is the elevation in the boiling point when the concentration of the solution is 1 m.
Yes, ma'am.
Elevation in the boiling point for 1 molar solution. How do you define rho? The resistivity.
Area is 1 meter, area is 1 meter square, length is 1 meter,
Ah,
and resistance is 1.
that's all. It is the resistance offered when the L is 1 unit and the area is also 1 unit square. We take it as 1 unit because here we don't use, when you are talking about solutions, we don't take 1 meter length container and all. We take it in centimeters. That's why. So when the L and A both are 1 and 1 unit square, the resistance measured is said to be the resistivity. Any problem with this?
No, no.
What is the unit of L upon A?
Meter inverse.
Meter inverse. Okay. What will be the unit of rho then?
Ohm meter.
Ohm meter. Okay. Now coming to the expression remains the same, but instead of using a metal, now we are going to use an electrolytic solution. So an electrolytic solution is not rigid, right? For a metal, you can you can stretch it out, make it longer, maybe reduce surface area, increase surface area. You can melt it, remold it into different shapes. But for a solution, can you do that? Is it a rigid substance?
No, ma'am.
So what we do is we prepare a cell. The cell here is nothing but a container. The cell is usually like in a honeycomb. Okay, we say each one is a hexagonal cell. Cell is a region. Okay, so here it is a cell. It's a container. Don't again go to electrochemical cell and all. So it's a container. It's a physical container, right? It's mostly cylindrical. There are two diagrams which are given. Okay, and an opening where you can pour the solution into it and use. And on each of the end, you have the metal plate embedded so that you can connect it to the EMF source. Are we clear? So this is said to be a container, or it is also said to be a conductivity cell. Don't misinterpret cell to be capable of generating current. It is using the current here. Is that clear? You can close it, pour the solution, actually close it and use it in leak proof manner. Any problem with this? Can we proceed?
Yes, ma'am.
Okay. See, here they have given you two, see, this is one of the models of a conductivity cell. This is another model used for similar experimentation. Is it okay? Both are conductivity cells. The container is filled with the solution. Here also it is filled with the solution and used. Okay, now we have got two important terms. Okay, what is that? We say R is equal to rho L upon A. Now, do you think this container will be of 1 meter length, 1 meter square cross-sectional area? That means I will have to put 1 meter cube of solution to do the experimentation. We are measuring
No, ma'am.
for a unit volume. So why not keep it in centimeters? Keep it small. And that's why I said in chemistry, where we are learning about the electrolytic solutions, the L is expressed in centimeters and area also in centimeter square. So the L upon A, it is the dimensions of the cell which is fixed. Now, it gets fixed because it is a rigid container and container's volume is going to be fixed. This L upon A, the ratio of L to A, is also called as cell constant. And it is represented with the symbol G star. Is that okay? The cell constant is represented with the symbol G star. And its unit is centimeter inverse. So what will be the unit of rho? Will it not be ohm centimeter?
Yes, ma'am.
Okay, the next important term. Okay, in physics, you would have learnt the conductance. What is 1 by R? Isn't
C.
it C, conductance? Similarly, here we don't want that, but we want this. What is 1 by rho? 1 by rho is called as conductivity. And this is actually a compressed kappa. We call it as kappa. Okay, the symbol is kappa. Like these are alphabets used in different languages. Okay, so this is kappa. Kappa is what? Kappa is conductivity. What is conductivity? It is inverse of resistivity. Like how inverse of resistance is conductance, inverse of resistivity is conductivity. Okay. So
Yes,
can
ma'am.
we now write that R is equal to rho L upon A? And can I now substitute this rho as 1 by kappa?
Yes, ma'am.
Where resistance times kappa will become the G star. Fine. Or
Yes, ma'am.
kappa will be 1 by R L upon A, or which is ohm inverse, centimeter inverse. Ohm inverse is also represented as Siemens. Siemen per centimeter. So kappa's unit can be Siemen per centimeter, Siemen per length. Since here we are conveniently using the cell of centimeter dimension, so we say Siemen per centimeter. Any doubt about this?
No, ma'am.
No, ma'am.
Okay. Now the question is, I'm going to do only one consideration and stop the class. Okay. Yes, Pranav, I'm not able to hear you. You're not interacting. Even yes, no is also not coming.
Yes.
Okay. So we are trying to understand the conductivity. Okay. So assume that I have got the cell here, the conductivity cell, which has got the metal plates, and I'm going to assume that I have got, okay, for simplicity's sake, I'll assume that this can hold 1 liter. The length of it is 1 unit. The area of cross section is 1 unit square, and volume therefore will be 1 unit cube, right? 1 unit
Yes,
cube,
ma'am.
correct? Volume is going to be, and for simplicity's sake, I'm going to consider that volume is 1 liter. For simplicity's sake, that volume is 1 liter, just for considering the effect of concentration on the conductivity. Okay, now I'm going to take, say, 1 m KCl solution. It's a very strong electrolyte, it dissociates fully. And I'm going to pour this. How much? I'm going to pour 1 liter. I'm going to pour this container can hold 1 liter, as I said. So I'm going to pour this 1 liter solution. When it is poured, how many moles of KCl goes in? When I'm pouring 1 m KCl, how many moles of KCl goes in? Remember, I have poured 1 liter. What is the meaning of this? Isn't it 1 mole per liter?
Yes,
Yes,
ma'am.
ma'am.
So if I'm pouring 1 m KCl and the volume that can be held in it, for simplicity's sake again, is 1 liter, how many moles of KCl is going in?
1 mole.
1 mole. Okay. If I take it as 2 m KCl, how many moles will go in?
2 moles.
2 moles. If I take it as 0.1 m KCl,
0.1 moles.
0.1. So do you understand that the ions are the current carriers, right? And with increase in the concentration, the number of charge carriers are increasing.
Yes, ma'am.
With the decrease in the concentration, the number of charge carriers are decreasing.
Yes, ma'am.
The volume is fixed. Volume of solution is fixed. So, can we say that with increase in concentration, there are more ions per unit volume? And since these
Yes, ma'am.
ions are the charge carriers, can I say that the conductivity increases with increase in concentration?
Yes, ma'am.
Same is the case with decrease. With decrease in concentration, there are less number of ions or charge carriers per unit volume. That's why we said unit volume. So that means if concentration increases, conductivity increases. On the other hand, if the concentration decreases, the conductivity value will decrease. Is that clear?
Yes, ma'am.
So what is the definition of conductivity now? See, we'll put it this way. What is the definition for conductivity? Again, R is equal to 1 by kappa L upon A, or we can put it as conductivity is equal to 1 by R L upon A. 1 by R can also be taken as conductance. Though in chemistry we are not using any term, any expression for it, simply. So can I say conductivity is the conductance of the given solution when placed between electrodes at 1 unit distance and area of cross section of the electrodes 1 unit square? Can we say conductivity is the conductance offered by the given solution of the given concentration when placed between electrodes of unit area cross section at a distance of 1 unit?
Yes, ma'am.
That becomes the definition for the conductivity. So two things we have learned. One, the definition for conductivity, and the second, how it depends upon the concentration. The conductivity is directly proportional to the concentration. Note this definition, page number 46. The conductivity of a solution of a given concentration is the conductance of 1 unit volume solution kept between two platinum electrodes with unit area of cross section and at a distance of unit length. Is it clear? Kappa is the conductance offered by the solution of the given concentration when 1 unit volume of the solution is placed between electrodes of 1 unit square cross-sectional area kept at a distance of 1 unit. Why platinum? Platinum is an inert electrode. It will not participate in the reactions. The solution will not undergo any reaction with platinum. This becomes the definition. Don't change a single word of this definition. And one more definition that we will study in the next class is the molar conductivity. Okay, which is slightly different from the conductivity. Okay, also we studied that conductivity is directly proportional to concentration. More the concentration, more the number of ions per unit volume. Is it okay?
Yes, ma'am.
Okay, with
Yes.
that we will stop the class today.
Can you show the notes?
Which one?
For one.
Ah,
The K is directly proportional to
yeah, 1 minute.
C.
Where is that? See, I'm stopping this. No, Ishan.
Yes, ma'am.
So when I